Hello everybody, I'm Marco D'Ambros, and this is the third part of how to create a Blendshape in Maya with Bifrost. In the previous two parts we saw how to create a target and add some feature like a delay map, the weight map, etc, etc, etc. Today we are going to visualize how to work on multiple targets. And to do so we are going to use a node called iterate. So one of the first things that I talk about Bifrost, so the prof about Bifrost is to be able to manage loop internally. Like if you have two array, internally is going to multiply each different element. But Bifrost give an option to have even another three types of iterator. So iterate, do while, and for each. All these three has a three different feature than we need for a different situation. There is a video that explain much better the difference between these three iterators, so I will leave the link in the description. So let's focus on iterate and why we need it. So what we want to do, so one of the cool things about iterate is to keep the state. So we can have an output node, an output plug, and we can pass back as an input for the next iteration. And so our plan is to do the same things that we did previously about build the delta and sum on our base mesh. But instead to use the base mesh, we are going to use the previous status. In this way, we can have one iteration per target until we sum all the vertex position and apply to the mesh. Let me show how to do this. So let me open a new empty scene. So this is just like a normal empty scene. I just created like a Blendshape in Maya and add an attribute called blend here. So everything is good. Let's go to create a Bifrost node. Like I remember, this mesh, I'll show you, is actually word mesh. So in case of the former, I do prefer to use outmesh, so we are now going to have the transfer value on the vertex position. Like we saw previously, we want to get point position and set them point position. These are the basic connection that we do all the time when we want to do like the form. Well, maybe not all the time, but that is a very basic standard practice. This is our out mesh. Let's build all our input. So this is our base mesh. So what we want is the target. So we create a value node, type object, and we want to have an array because we want to have a multiple target, and we don't want to define how many numbers, so it's an array and we can plug how many we want. We want to blend, and we want to have so it's a float, and we want to have an array because we want to have a blend per shapes. Blend. And we even want to have a blend default value, and I'm going to explain in 1 second why. It's not a need, but it's I recommend to do it. Blend default. Okay, let's start to connect the mesh. This is our cube. So this is target number 1. Let's say out mesh. Oh, sorry, I did not rename it this one. Target mesh. So out mesh, target value 1, and of course out mesh, target number 2. So why we want to have a blend default? So when we create an attribute, like in this case, the attribute is come with the default value, in this case 0, but can be any default value. When we instead we create an array, like blend, this is an array, the default value is empty array. So this means we don't have any default value. What we want to do with this attribute, blend default, is if you do not define this one, we are going to use the blend default for that mesh. Let's actually already connect with our blend value. So we want to have this mesh here, this transform here, because I create the attribute here, but it, you know, doesn't really matter. It's not here. Here we go, blend, and we connect to our blend default for now. So what is the first steps in this situation here? So we want to have a blend default per mesh. So let's create an empty array. So results array. This results array allows you to create an array with the default value, and this is our default. And the new sites. So we want to have a base that is blend. So we start with this array, the blend array, and if the number of elements are minor than the new sites, it will be filled with the blend default. So to do so, we go to do array sites and add like this. So this is actually, this node it's made to create like a, you know, increase the value or decrease if you want, and increase the length of an array, but we can use even to create a default array with a fixed, well, with the element, in this case the number of blends. Sorry, this was my mistake, it's the number of targets. So we want to have number of targets, and this will be our new blends value. It's cool. So now that we have this one, we can jump on iterator. Let me redesign what we want to do. So a little bit of theory. So we want to create an iterator per targets. So we have target 1, target, maybe yellow, it's work better. Target 1, target 2, target n. We want to create a delta. Of course, the delta we are going to multiply with the blend, etc. So we do what we did in all the previous tutorials. So you can add whatever you want here. And we are going to add to our default mesh. What we need to add is the iterator. So this output is gonna be replace our default mesh. So first we want to define this default mesh 0, like when we don't have anything yet. So like similar to this one, so we can copy and paste. We can get all the vertex number of a mesh. We don't need this default. We don't need this one. So this is our 0 default delta. So we want to have as default type a vector type 3, and we want to add as a size of the number of vertices. So we get the number of vertices, and this will be a new array with the same number of vertices 0, 0, 0. So actually, if I'm going to plug this one, for example, we're going to have a 0 mesh. So now let's create the iterator. What we need is our target mesh. We want to have our target blend. We need our point position. Let's do that. And we want to have our delta. So in this delta, base pp blends. Let's go this side. So one thing then we can notice here, then our target mesh and blends are arrays, but we need a single element. So to do so, we can right click. Let's go to set port iteration type true. If you see, now it's changed the icon on a single element, and you can see like a new icon inside. That is mean is an iterator now. And let's do the same with the blend. So we're going to iterate this one over and over again. Base pp and delta, it's okay, there are actually an arrays, because these are our vertex position, so it's an array of vertices. So we want to have the delta here, So the other things we want to see, we want to have this recycle state that we talked, the red line. So when you're here, you can do right click, set port states, and you can decide which mesh you want to bring back. So let's say delta at the moment. This connection it's not correct, but doesn't really matter. So now you see this is symbol, then your this plug here is gonna be the delta on the next iteration. So let's do what we did for the normal Blendshape. Like this is absolutely what you already see in the previous video, nothing more, nothing less. So get point position of our target mesh, create our delta, let's say local delta. This is our target PP. So we have our base point minus our target point. Oh, sorry, actually, this is our target. I was confused. We want to start with a target. So we have base point minus target point. So now we want to multiply with the blend. Multiply with the blend. Where you go? Actually, let's skip this one for 1 second. So let's try to plug this one here. Because we want to add back. Oh, I want to show you. So now we build the delta. Let's connect this one here. Okay, we don't want to visualize this one because we have the bypass one. Cool. So now we have our differences. I'll show you. If you see now nothing is moved, but if you move this one, it's moving. So we actually getting the delta only of our second target. This is because we are not summing back. We are just connect directly this one here. So the first loop is getting here, it's coming back here, nothing happened, and just complete the second iteration, and we just receive back only the second iteration. So what we have to do is this plus with our delta. So we have our local here, multiply our delta, previous iteration delta, and now if you see we have both together. So if I move this one or if I move that one, I have both the vertex together. Cool. And like I say, the reason is because we do the for loop, the first iteration where we're going to build the delta. We go here in the out delta, and that is our start point, and we are going to add on the second iteration, and so on and so on and so on. So let's say multiply. Let's add this one on the multiplication. So this is 0, so it's fine. And to 1, so we have our Blendshape. What we're missing here is the add back to the point position, because we have just computed the delta in that iteration. Here we go. Like you say, now we have a normal Blendshape like Maya, where we are summing the two elements of each other with each other. So it's cool, it's okay, but let's see like one of the options that we can do now. So just to see how you can implement with a new feature. Have the sum of the Blendshape can be useful, but I don't think it's the solution for every situation. Sometimes I just want to have one target, and that is our goal. Doesn't matter how many mesh are one on top each other. So we can create some rules for that. For example, we are going to do like an example now with the max. So what we are going to do now, we are going to do the same iteration, but instead to sum, we're going to select which vertexes as the maximum length of the formation. So this is our base mesh. This is our new target, the previous, the actual one, target previously. We are going to compare length target. We are going to compare the length, so the magnitude of the first vector, if greater or less than the second one, and we're going to select one of the two. And this, doing like this, we are just only using which one is the highest, so the one that give like the most extreme pose until we are going to on the final pose. So let's create first the enum, then we are going to define is gonna give it the switch. So let's create a, let's create an attribute on here. Add attribute is say enum. We want to have add, that is default my behavior, and we want to have rate or max. Max, I do prefer max honestly, but it's just a name, so doesn't really matter. Blend type. Cool. And we want to add this one as an input of our Bifrost node. Something that I never showed you before, you can have input nodes. This actually is going to create only one. It's the same to add like the attribute like we did before. The good things about to have a separate input is just to have like a cleaner graph, so you don't need to have everything start here and have like a long connection anywhere. We can just create one here. It need to be an integer value. Integer value. This is our blend type. So now we can connect our blend type to our blend type, and we want to bring this one here. So let's do the same things. So first of all, we want to have a condition. So let's create another input. Actually, that it was my fault. Let's disconnect this one for 1 second. Delete this one. And let's create blend type here. So now we have the same input. Let's connect. So we want, let's create a node for the status. So we want to have equal. If this one is equal to 0, so it means it's an add, or if it's not, we're going to do the max. Or we can do the vice versa, doesn't really matter. So this is the add. So if condition, this is our boolean. If it's true, it will be add. Well, now we do both, but we're going to. If it's false, it will be the new system we are creating right now. Here we go. So nothing now change, even if we are changing the type from add to max. Cool. Well, actually, because I did not connect it. Here we go. Add max. Nothing really changed. It's good. So we said that we want to compare the magnitude, so let's get the magnitude. So go to the multiply, we get the length, so the length of these vertices compare the length of our delta. Let's get which one is the greater. So this length and this length. This is our delta len. This is our delta local, local len. Let's create another condition like previously. So it's very easy, if you can see. Disconnect our boolean, and now we want to switch. When this length is max, we get this multiplication here. Yes. Here we go. So we are going to actually, this if is our add. We're going to substitute that one. So multiply if it's true. If it's false, we get our normal delta. And this is if this condition is false, so it's not 0. So we have nothing changed because we are in add. Let's go to max. Here we go. So what's happening here? Let me show you. So you see the two poses. What's happening, instead to sum, like for example in this case, we have these vertices. These vertices go double of the distance here because we have this one plus that one. Instead of this situation, we are using the maximum value of these two. And I'll show you better, like just increasing this one here. So now if I push this on there, if you see, it's going up. But if I move this one, as long is less than the target, the other target, it does not move it. But it's moving as soon as I put it like bigger length, higher length. And the same here. It's easier to see from this side. See, nothing move until something will start to move because it's longer. And that's it. So in this case, we always have a final target, and you know that you never go further than that. So you always know what is the final pose, and was it change the iteration in between. So when you move it, you can have one or the other one, depends how are the poses. It's 20 minutes. Let's call the day for today. Thank you very much to follow, and as usual, just write any comment and feedback below. I will be super happy to read it. Thank you very much. Have a lovely